Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic of momentum and collisions with the title Momentum. So let's talk about what momentum is, since this is the first one dealing with momentum. I like to define momentum as how hard an object is to bring to a stop. Okay, so what are the two things that make an object hard to bring to a stop? One is how fast it's moving. The faster something's moving, the harder it is to stop. Like take a bullet, for example. Okay, it's not particularly easy to stop because it's moving so fast. The other thing that makes something hard to stop is because of how massive it is. A train rolling at you very slowly still has a lot of momentum. It's still pretty hard to stop. Of course, a train moving fast is much harder than either of the two previous examples. Keep in mind, if an object is stationary, that means it's infinitely easy to stop because it's already stopped. So it has no momentum. Our equation to calculate this is P equals mv, where P is the momentum, which is a vector, and that's going to come into the wizard level especially. It's how hard an object is to stop, and its units are kilogram meters per second. Lots of units will have derived units where you just have one thing, like a Newton, but in this case, we have to have our combination unit, kilogram meters per second. So momentum is mass times velocity. Mass is the amount of matter in an object measured in kilograms. We've used that for a couple years now if you took chemistry already. And velocity is a vector also, meaning it has a direction, and it's how fast the object is going in meters per second. All right, so just a couple of examples here. A plane flying through the air would have a big momentum because it's both very massive and it's moving very quickly. An ant crawling along the floor would have a small momentum because it's got a very small mass and a very small velocity. And a plane sitting at the taxi at the terminal would have no momentum because it's not moving. Okay, so keep in mind you have to have both. If you had something moving without any mass, it would have no momentum also. But I don't know of anything like that because light, even though it has no rest mass, has mass when it's moving. That gets beyond where we need to be right now. Let's move on to the apprentice level. What's happening with momentum? So mass is always constant in this level. It gives you three options, and you have to say which one has more momentum. Or, I can't remember now what it does. Let me pause a second and figure that out. That's right. I just double checked. It doesn't. It wants to know whether the velocity is increasing, decreasing, or remaining the same. So what you need to be looking for is what's happening with the velocity. Since the mass isn't changing at all, if the velocity is increasing, the momentum is increasing because we got a direct proportionality here. If you need a review of direct proportionality, I'll link that here. But if the velocity is increasing, the momentum is increasing. If the velocity is decreasing, the momentum is decreasing. If the velocity is constant, the momentum is constant. Okay? All right. So that should easily get you through the apprentice level. Moving on to the master level. So the master level has a little diagram like this, and there are two ways you can go about solving the master level. One is by looking at the relationships, and that'll get you through a couple of them. Keeping in mind, mass is directly proportional to momentum, so is velocity. So in this case, you see all the velocities are equal. So then just the bigger the mass, the bigger the momentum. Smaller the mass, the smaller the momentum. But there are a few where both of them are changing, and so you'll need to be able to do a calculation. Okay. Oh, I meant to have that come in one at a time. Oh, well. So if we're trying to find the momentum in order to be able to rank them, we need to find what we've got. We see for A here, we got the mass is 4 kilograms because kilograms is a measurement of mass. The meters per second is a measurement of velocity. So we have the velocity is 2 meters per second. Once we see the three variables we need in our equation, P equals mv, you can look on your equation sheet or whatever equation you're using. But for this concept builder, it'll always be P equals mv. This is already solved for what we're looking for, so we can skip my step 3. By the way, if you're wondering what these step numbers are, I'll link a video where I show how I solve problems using the 5-step method. Step 4 is to plug into the variables. So we had M, so M was 4 kilograms. So for M, we plugged in 4. V was 2 meters per second. So for V, we plugged in 2 meters per second. And we multiplied 4 times 2 to get 8. Kilograms and meters are in the numerator, seconds in the denominator. We have kilogram meters per second, just like we should for velocity. If we continue to do this for the other two, we see here we have 2 mass of 2 times a velocity of 2. So that'll be 4 kilogram meters per second. Here we have a mass of 1 and a velocity of 2. 1 times 2 gives us 2 kilogram meters per second. And this one we got down here was 8 kilogram meters per second. And then you just rank which one's biggest. 8's obviously the biggest, 4 is the middle, and 2 is the smallest. All right, so that's just plugging into a fairly simple equation there. All right, and moving on to the wizard level. In the wizard level, getting direction on momentum. Basically, just remember that momentum is a vector and velocity is a vector. So velocity is the vector over here, and that direction determines the direction of the momentum. The direction of the velocity is the direction of the momentum. So if it says the car is going north, then the momentum's north. If it says the bowling ball is rolling to the right, then the direction of the momentum is to the right. Whatever direction it's moving, that's the direction of the momentum. All right, enjoy puzzling out these on Momentum Concept Builder. If you have any questions, put them in the comments below. If you enjoyed this video and helped you to solve the Concept Builder, go ahead and click the like and subscribe, and we'll catch you the next time on the scientific adventures of Beardman.